For episode 7 of fractions, let's have a look at the operation of division. And we're first of all going to start off just by dividing a common fraction by a common fraction. So remember from previous episodes that division and multiplication are inverse operations. And we can't cross-cancel when there's a division sign. So what we're going to do is we're going to change the division sign into a multiplication sign, using a trick which most people call tip and times, but I call times and tip. And the reason that I call it times and tip is because then it tells you the order in which to do the timesing and the tipping. I just find that when I say tip and times to people, they often tip the incorrect fraction, because we move from left to right as we're working through each step. And if we move from left to right, you'll see now that times and tip makes more sense. So what I'm going to do is I'm going to leave the first fraction exactly as it is, and then I'm going to convert the division sign into a times sign, and then I'm going to tip the second fraction, which means I'm going to invert it. The proper mathematical word is to invert it, and when we invert it, we make the numerator become the denominator and the denominator become the numerator. So we're going to have 14 over 5. So as soon as you have a division sign, you make sure that they're in the form of a number over a number divided by a number over a number. In other words, if they're mixed numbers, you have to go through that step of converting to improper fractions first. And then once you've done that, write down the first fraction, change the division sign into a times sign, and tip the second fraction. And now that it's become a multiplication question, you know how to do multiplication. So we're going to cross-cancel or cross-multiply. So looking diagonally here at a denominator and numerator, what will go into both of those numbers? 7. So 7 goes into 14 twice, and 7 goes into 21 3 times. Then if I look the other way diagonally, I've got a numerator and a denominator that are both divisible by 5. 5 goes into 5 once, 5 goes into 10 twice. Remember that I can even check like this because it's still a numerator and denominator, but they don't belong to the same times table. So now I just need my tidy up step, which says numerator times numerator is going to give me 4, and denominator times denominator is going to give me 3. That is an improper fraction because the numerator is bigger than the denominator. So using that fraction line, remembering that it means divide, 3 divides into 4 once, with a remainder of 1, which I put over my denominator. Right, let's have a look at an example where we have mixed numbers. So we're going to look at 1 3/5 divided by 3 5/10. So if we presented with mixed numbers instead of common fractions, we just have to do that first initial extra step of converting to improper fractions. 5 times 1 is 5, plus 3 is 8 over my denominator. At this stage, leave it as a division sign. Don't try and do 2 steps in one. That's where people come short. 10 times 3 is 30, plus 5 is 35 over 10. Right, now I need to times and tip. So that means I write down my original fraction exactly as it is, change to a times sign, and tip that one. Okay, so if we have a look this way, do 8 and 35 belong to the same times table? Definitely not. So nothing can cancel that way. Do 5 and 10 belong to the same times table? Yes, divide 5 by 5 and divide 10 by 5, and we're left with 2. So looking this way, nope, that's an odd number, definitely not divisible by 2. What some people do at this stage is they get carried away and see the 8 and the 2, and they realize, they belong to the same times table. They're both divisible by 2. but you may not cancel numerator with numerator. So don't be tempted by that. There is nothing else that will cancel. So tidying up, I've got 8 times 2 is 16. And at the bottom, I've got 1 times 35, which is 35. That looks like a bit of a weird fraction, but there's nothing that can divide into both of them. It is a common fraction because that's smaller than that. So there is nothing else I can do to it. And that is my final answer. Let's have a look at 2 and 11/12 divided by 3 1/3. First step, if it's mixed numbers, convert to improper. You should be getting really good at this method now. 12 times 2 is 24. 24 plus 11 is 35. Over 12 divided by 3 times 3 is 9 plus 1 is 10 over 3. Okay, now I'm going to do times and tip. Leave the first fraction exactly as it is. Change the division into times and tip the second one. Okay, so looking at my diagonals, we obviously got a numerator and a denominator. Let's look at those two first. What will go into both of them? 5 goes into 10 twice, and 5 goes into 35 7 times. Looking at these two, we've got 3 goes into 3 once, and 3 goes into 12 4 times. Anything else that will cancel? No, so I just need to tidy up. 7 times 1 is 7, and 4 times 2 is 8. Check whether it's improper or common. It's a common fraction because the numerator is smaller than the denominator. Nothing else can be divided into both those numbers, and so that is my final answer. Let's end off with one more of 7 and 7/8 divided by 10 and 1/5. Converting to improper fractions, 7 times 8 is 56. 56 plus 7 is 63 over 8. Keep your division sign while you're just converting to improper fractions. 5 times 10 is 50, plus 1 is 51 over 5. Now I do my times and tip step. This one stays the same. Divide changes to times, and tip the second fraction. Right, now we need to look at cancelling. So if we look this way, there's no ways that anything will go into 8 and into 5. Looking this way, this also doesn't look very hopeful, because we know that 63 is part of the 9 times table and the 7 times table, but 51 doesn't seem to feature in any of our tables that we learn up to 12 times table. So let's go right back to things that we've learned in the past. How do we find out when something is divisible by 3? What's the trick for finding out if a bigger number is divisible by 3? I hope you've remembered that what you have to do is to add the 2 digits of the number. So 6 plus 3 would give me 9. And then you ask yourself, is 9 divisible by 3? Is 9 part of the 3 times table? Yes. And I think obviously that is divisible by 3 anyway. But now let's check this one as well. So I need to add the 2 digits. 5 plus 1 is 6. Is 6 divisible by 3? Yes. So therefore this big number is also divisible by 3. So let's divide this one by 3 first. So we don't know exactly what the answer is going to be because it's way past 12 times 3 that we usually learn up to. So we're going to pretend that we're going to divide 3 into 51, but I want to show you a shortcut. So we would start off by saying 3. Well, let's do it here and then see how it translates to there without doing that. So 3 into 5 goes once, remainder 2, and then 3 into 21 goes 7 times. So without drawing that, we could do it straight away here. And remember that when we're dividing, we work from left to right. So 3 into 5 goes once, and then I put the remainder 2 there to remember that I have to carry it over. And then 3 into 21 goes 7 times. So you can do short division like that without going through all this process, and it will save you time. This one's fairly simple. Again, working from left to right, 3 goes into 6 twice, and 3 goes into 3 once. Right, let's check this way now. Can anything go into both those numbers? No. Into both those numbers? No. So that is all we were able to cancel. It wasn't very much. So now we need to tidy up. So we've got to say 21 times 5. So instead of writing down again 21 times 5, just remember you would start at the units. So let's do exactly that. 5 times 1 is 5, and then 5 times 2 is 10. So that's my numerator. And doing the same thing here for 8 times 7. Remember, I would start off by saying 8 times the units. So 8 times 7 is 56. Carry the 5. 8 times 1 is 8, plus the 5 is 13. Wow, what huge numbers to have in a fraction. But because we were so careful to make sure that we couldn't cancel any further here, we know that there's nothing there. Well, let's check for 3, because 3 can throw us sometimes. So we've got 1 plus 5 is 6. That's divisible by 3. 1 plus 3 is 4. 4 plus 6 is 10. 10 isn't divisible by 3. Are they divisible by 2? Is that an even number? No, it's not. So that's not divisible by 2. What about dividing by 5? Well, divisibility by 5 says they must either end in a 5 or a 0. That ends in a 5, but that doesn't end in a 5 or a 0. So even though they are such huge numbers, that is the most simplified version of that particular division cell.